Good evening, everyone. And as you know, in this chapter, we are extending this a little bit longer as usual. What I feel. Okay. So this is your Einstein P effect. In this particular class, what we are going to discuss the quantum phenomena, the quantum aspect. What is a quantum aspect? Okay. Obviously, we starting with the characteristics of photoelectric, with then energy or quantum of radiation. What is the energy quantum of radiation? We already discussed E equals to h nu. Then energy quantum of radiation, how it is going to be emitted on the basis of quantum phenomena or on the basis of wave phenomena. Okay, or you can say treated as a wave. Obviously, treating as a wave, it is not going to be done. Then energy quantum of radiation, and then relation between stopping frequency. That's I already given to you. So in a proper way, it is. And then relationship between stopping potential and this wavelength, and then verifications of law of photoelectric emission based on Einstein photoelectric equation. Okay, so that we are going to discuss. Then graphs related to photoelectric effect from Einstein photoelectric equation, that is important, and few important graphs in this. Then particle nature of light, the photon and the properties of photon, different characteristics of photon, and then photocell. The important thing in this class is going to be photocell. Okay, photocell is nothing but the reverse of a LED. What is LED basically in general? LED, light emitting diode, is a kind of a diode, or it is a kind of an instrument in which light is going to be emitted, in which the electric current is going to be converted into the, or basically electric energy is going to be converted into the light energy. So in a same sense, photocell is a kind of a cell which is going to be used as a photon. It is a device that converts light energy into electrical energy. Got it? And LEDs you can understand more easily, more you can say beautifully, more clearly, because in coming months we are going to use so many LEDs. LEDs means you can say the LEDs, the light, the small lights bulb with which we can decorate any particular thing, either the wedding house, either the houses, street, shops, anything. Okay, these are the basically LEDs, right? So in Diwali, or in the month of Diwali, specifically in across all over the country, not only in north, in south, in east, in west, everywhere, we decorate our homes just for the Diwali, because of to worship the, you can say, goddess of money or wealth, which is Lakshmi, right? So we make our house beautiful. We clean our house from top to bottom. We decorate our houses, rooms, wherever we live or wherever we are. Clear now, everyone? So this is all about the Diwali, and then why this Diwali came into the picture right now. Because in Diwali, most of the time you can see the decoration is done by the light, the small bulbs. And these small bulbs are basically the LEDs, light emitting diode. The phenomenon of that particular LED is to convert the to convert the electric energy into the form of light. Clear? If there is a power cut, if there is a no light in that particular area, in that particular, you can say, society, your home, or anywhere, so the LED is not going to work. So in a same sense, or you can say in that analogy, we have one instrument, we have one cell also, which done the reverse. Okay, and that reverse thing is photocell. Photocell is basically what it is like. We In photoelectric effect, what we are basically doing, we are converted this light energy into the electrical energy. In a same sense, the photocell does this job. Okay, that is an instrument which can convert your light energy, visible light energy, photons or radiation, into the form of electrical energy. Clear? And quantum phenomenon and important graphs we are going to use, because whenever the Einstein P effect, or you can say you get to know, Einstein get the Nobel Prize on this P effect as well as the spatial theory of relativity. Okay, Einstein gave 2 3 important relations, or you can say laws. First one is energy can be converted into mass, or you can say mass can be converted into energy. energy mass equivalence, E equals to mc square. The second thing is P effect. Photoelectric effect is given by the Einstein. So what it is given, how it is given, we are not going into the depth, but on the basis of that, he got the Nobel Prize, as well as with the STR. What is STR? Spatial theory of relativity, in which when an object is start moving with the speed, approximate speed, you can say 0.5, 0.6, 0.4, or of the order of velocity of light. So the phenomenon is going to be changed. Phenomenon, I'm saying, phenomenon is going to be changed, but the laws of physics going to be remain same. Clear? Means length is going to be contract, time is going to be dilated, and there is a one beautiful story, or you can say not story. There is a one beautiful concept, time dilation. What is the time dilation? If two twins, uh, if the two twins, one, if we send one of the two person from a twin out of this space, or you can say out of the earth, okay, one of the twin become a astronaut, and that astronaut going away from this planet, or you can say out of this earth, and stay in an you can say outer space in any particular you can say space shape, or anywhere out of this planet. So the in the same time, or you can say after 10 years or 15 years, the age of that particular person which is out of the earth is going to be less, or he looks younger, he remains younger, and the person at the earth is looks more older. This is you can say phenomenon of a physics which is known as what? Time dilation. What is the time dilation? Time dilation is a particular physical phenomena in which time going to be delayed if an object is thrown approximately with the speed of light. Okay, and obviously if we throw any particular satellite out of this earth, or you can say in particular open space, so what happened, that is start moving with the speed of light. So whatever the number of people remain there in a spaceship, in a satellite, so they don't get aged as much, as much as quickly we are aged. And how we can recognize this particular? Just if we send one of the brother or a sister from the twin pair, because twin are the particular pair of a human beings which take birth almost together, or with the difference of 1 second, 2 second, or a minute max to max, right? So then you can easily find it this thing, that one of the twin, or you can say one of the person from the twin which is remain, or you can say which is stay at the particular planet earth, that gets older as quickly. Clear? Means time going to be delayed. Time going to be delayed means it increases. Clear na? And the time is not going to be much for the person, for a astronaut, or you can say for a person which you can say stay outside this planet. So that everything concept and that everything you can find on YouTube or anywhere. So you can get more interest into this particular phenomenon of physics. There are so many one thing. Okay, tell me, do you know parallel line can intersect with each other, but they are in general. Yes, whenever parallel lines we draw on a planet Earth, okay, so they can intersect with each other. This is you can find also on Google. Sorry, on YouTube. There is one beautiful concept. Okay, as you can see, Earth is going to be subdivided into two parts: equator, or one is you can say equator, or another terminology is what? I don't remember right now. Okay, there are two lines. Just a minute. Okay, so Earth is divided into two shapes like this. So one is known as equator. Or another is known as axis. Something like this. Means you can cut it out. Earth in two ways, na, horizontally or perpendicularly. So now you can see they are overlap because Earth is a sphere. So when they are overlap, so they seems parallel to each other, but they intersect at the at the same time also. And that is why, how sir? And that is why the time, or you can say you can find if you take a flight at 5:30 p.m. from Dubai, so you can land at 5 p.m. in Florida because of this concept. Because Earth is rotating, so you get back into the time. Okay, so there are so many concepts like the flight attendant, whosoever attend the flight at the particular airport like Dubai or in Western countries, they need to use the two watches, EST or IST, Indian Standard Time, as well as the Western Standard Time. Okay, these are happening in real, and we have a Tokyo to New York, same like that. Yeah, Tokyo is in east, which is Japan, and New York is in the west. The same example I given. Because what happened when, see, suppose you standing on, this is the east, right? Suppose this is east and you standing here. So for you, the sun is already arise and the morning is done. But the moment you reach at that particular part west, meanwhile this earth is also rotating. So again it become, this west, the sun is coming at the west right now. Right? Clear na? Because earth is rotating on its axis and along the sun also. So the sun rays at the same time here. So where the time gone? Time nothing going anywhere, but you reach from east to west. So again the sun is rises and you seems like it is morning again. We reach at the same time, the time we are flying. So these are so many concepts like this. Okay, if you get more into the depth of physics, got it? So okay, sorry, where from I start and where I reach. So something like this we are going to not seen right now in class 12, but something like this you are going to see in graduation as well, if you took physics as a part at least. Okay, and so many other theories are also related and also done in the physics, like the nature of a waves, how they can move, and you can find the concept behind that, the proper concept. So many things are you can explain only on the basis of physics, and you can say, and there are so many concepts, like one is also known as butterfly effect. I hope and I believe you know the butterfly effect is. What is a butterfly effect is, if in any particular forest the huge amount of butterflies are going to take participate in a flying from one region to another region, so the tornado is going to be arise on the another region, or the, you can say, tsunami or so and so. And sometimes it is, not sometimes, it is happening in real also. Okay, so these are some highly, you can say, time taken and advanced phenomenons. If you want, so I can discuss some of them in DRS. Okay, to make you fall for physics. Everything you can explain like this with the help of physics. Okay, back to the topic. So Albert Einstein published an equation to explain this effect in 1905. Okay, and that is the name, the wonder year of physics. Light, according to Einstein, is a wave. Okay, according to Einstein, that is a wave that interacts with matter as a packet of energy or a quantum of energy. The photon was the quantum of radiation, and the equation known as Einstein's photoelectric equation. And he got the Nobel Prize on for this also. Clear, everyone? So that is just a beginning and a theory. So Einstein's photoelectric effect, the same photoelectric effect, nothing changed. When a substance absorbs electromagnetic radiation, electrically charged particles are emitted from or inside it, resulting in the photoelectric effect. Okay, what it is now, it is something new. As we know, any particular till now in the beginning, or you can say from the previous book, from the first book, we understood any particular radiation, right, or any particular light source is containing EM, or it is basically EM wave. What is a EM wave? Beta, EM wave is electrically or magnetic, electric field or magnetic field, right? A wave which contains electric field as well as magnetic field combined in that way, so they can move perpendicularly, and the direction of propagation is perpendicular to both electric field as well as magnetic field. Clear? So if any particular material, now I draw a material something like this. Okay, so if this particular rays are going to be absorbed in this way with the help of EM waves, or you can say as the analogous to the wave, so they you can say give a particular kind of a particle, or that particular particle is very electric. Okay, so electrically charged particles are emitted from or inside it. Means obviously when you give energy to something, so that energy is going to be used. Either that particular object, either that particular system contain its energy and increase its energy. But at a particular time, everyone have a, you can say, certain final limit. So when this energy is going to be crosses the final limit, what I am saying the final limit, the threshold value. The moment this particular EM waves and the electrically charged particle having more energy than the threshold, you can say energy, they can emit the photons. They can emit the electrons, and that basic electrons are known as photoelectric effect because they are emitted by the photons or EM. Clear na? This thing. So the phenomenon of emission of electrons by certain substance, any particular substance, metal, when it exposed to radiation or suitable frequency is called as a photoelectric effect, and emitted electrons are called photoelectrons. We have already done this thing on the basis of what? Particle. On the basis of what? Photons. Okay. But if you want to understand, I'm saying just understand. Obviously, this particular effect you cannot, you can say, learn on the basis of wave nature. But wave is, you can say, that particular wave is made up of a charged particle. When a charged particle starts moving, it creates a magnetic field altogether. If a charged particle is moving or or even at a rest, so it creates an electric field. So with the help of electric field and moving, or you can say magnetic field altogether, we have a wave, and that is a EM wave, and that is a radiation, any particular visible wave. Got it now? So either you can learn more basically on the aspect of particle, or either you can learn on the basis of wave, because that even wave is automatically made up of charged particles, moving charged particles. Characteristics we already done, so I'm going to do this a little bit quickly. For each particular photosensitive material, now what is the meaning of photosensitive material? You cannot get photoelectric effect from any particular material. The material which is photosensitive, which is going to react whenever a photon is going to intersect, okay, or going to interact. Photosensitive material, there is a minimal cutoff frequency of the incoming radiation known as a threshold frequency, below which no photons, electrons are produced. So that is important one, and we already discussed this thing in a great detail. Okay, the threshold frequency varies depending on the metal. As I already discussed this thing, work function, that is h nu naught. This nu naught is dependent or material dependent. Material dependent. It is not dependent on any particular source or anything, but it is dependent on material. Okay, it is basically material dependent. Material dependent. Got it? And that is what it written over here. The photoelectric current is directly proportional to the intensity. Again, intensity, why? Because intensity have an amplitude square, and amplitude square basically the how much number of electrons is going to emitted by this intensity for a particular photosensitive material, and the frequency of incident radiation above threshold frequency. Until unless the frequency is going to be, frequency of a radiation, I'm going to write radiation is not going to be more this threshold frequency. So that is the photoelectric effect is not going to be that. Okay. Necessary condition. This is your necessary condition. This is your necessary condition for P effect. Got it? We already read and write and learn this thing so many times. PE effect. Okay. So let's move away ahead. Above threshold frequency, we already done this thing also, but it is important also. Let's revise this. So above threshold frequency, we know the maximal kinetic energy of the emitted photoelectrons grows linearly with incident radiation frequency, but it is independent of incoming radiation intensity. What it is written over here, like above, once your frequency is going to be at the threshold frequency, so the kinetic energy going to be increases as per to the radiation intensity, as per to the this you can say incident radiation frequency. Okay, but independent of incoming radiation intensity. Your kinetic energy does not depend on this intensity. The number of photoelectrons are, but kinetic energy not. Emission of photoelectrons occurs in an instant. You can say 10 to the power minus 8 seconds, or I can give you the range 6 to 10 to the power minus 8 seconds. That is why it is known as instantaneous process, or it occurs as instant. There is no time lag between irradiation of the metal surface and the photoelectric emission, and that we already done. This is the range. Okay, what it is? Okay, let me time range for emission of emission. Even we already done this thing for the emission of photoelectrons. Here I guess and I believe, not guess, I believe this thing. Everyone know what is the meaning of photoelectron. Clear na you guys? Or do you have any confusion in this till now? Photoelectrons. Okay, photoelectrons are basically the emitted electrons which emitted because of photon, as simple as that, in the photoelectric effect. Okay, moving ahead. Now this is also we done. What is irradiation? There is no time lag between irradiation of the metal. Irradiation means whatever the radiation is going to be hit, and you can say this particular radiation is going to give you the photoelectron. That is irradiation. Okay. Now on this particular head, this is just theory. In 1905, the Albert Einstein explained the various law of photoelectric effect emissions on the basis of Planck's quantum theory. Okay, what is Planck's quantum theory? First of all, see, before 1900, whatever we learn till on the level of atom. Okay, because this atom is not going to be discovered in more detail. But when we discovered atom in a more detail, so what we can see or what we can find, we can explain every particular thing on the basis of waves also. Clear? Even we have a matter wave. Okay, in the higher classes, in the graduation, you can learn this concept, matter wave, because these are small tiny charged particles, which is an electron, proton, neutron, or chargeless, and they are always in a continuous motion. So when they are always in a continuous motion, and we know whenever a charged particle is in motion, so it creates a magnetic field, right? And it creates an electric field. So we can find matter waves also. So this is basically Planck quantum theory. Or many particular phenomenon we cannot explain on the basis of classical mechanics. Classical mechanics take every particular aspect object as a particle thing. Wherever quantum theory can take every particular aspect, even the objects, as a wave nature, as a wave. Okay, so that is Planck's quantum theory. Max Planck. Basically, Max Planck gave four equation important related to the electric field and magnetic field. Clear? There are the energy, you can say electric field, or you can say uh, charge density divided by epsilon naught, and divergence of magnetic field is zero. I mean, del dot E is sigma, or you can say upon epsilon naught. Del dot B is zero. Curl of E gives you minus del B by del T, and curl of H, or you can say curl of B, gives you curl of B is gives you 1 by mu naught del J by del T. Means if you change the electric field, you can get the magnetic field, time varying magnetic field. If you change this particular change means move. If you move the electric field, you can get the time varying magnetic field. In the same sense, if you move the magnetic field, you can get the time varying current J. Okay, so everything is correlated, and this correlation can give you the wave nature for each particular thing. So that is your Planck, Max Planck's equations. So this is a quantum theory. I mean, quantum theory can correlate, can teach you everything on the basis of wave. So according to that theory, the energy of an electromagnetic wave is not continuously distributed over the wavefront of waves. Instead of this, these waves travel in the form of discrete packets or bundle of energy called quanta of energy of radiation. Okay. See, in the previous chapter, Huygens principle, right? In Huygens principle, we states that this thing, if it is a source, so this source is going to give you this wavefront. Okay, and this each particular single particle, okay, in this vision, each particular single particle on the wavefront is a source of the next. So basically, what happened in this case, the energy is going to be flow in a continuous manner. This is the flow of energy. You can assume that. Okay, and then we have the next wavefront, and then we have this same thing. It is going to create more. Okay, and then beta, it is going to create even more. Then we have next wavefront, something like this. Okay, this is we understood in the previous chapter. So instead of that, what is happening in real, the packets are going to be distributed. And these packets are known as quanta of energy. 1 E equals to h nu. Is this clear? Means instead of this continuous transformation of energy, we have something like this. We have something like this. This is your one packet. This is your another packet. Okay, this one is your third packet. In this first packet, we have this. In the second packet, we have this. In the third packet, we have this. Clear enough? And these packets of energy are known as quanta, or one quantum of energy. These packets of energy is known as this quantum. Each quantum of energy radiate an energy which is given by this formula E equals to h nu. So this each packet having energy which is E equals to h nu. Nu here is frequency, not velocity. This is not velocity. This nu is frequency. Frequency of what? Frequency of this moving charge oscillating particles. Got it? Got it now, everyone? Clear? So where h is a Planck constant and v is the frequency of the light radiation when when a quantum of light radiation of energy h nu falls on a metal surface, okay, falls on a metal surface, then this energy is absorbed by the electron and is used in the following two ways, and the two ways are going to be described on the next page. Okay, the two ways are basically, we know, first it is emitted energy, or you can say it is emitted not energy. The first way is it is going to emit an electron, that is known as photoelectron, and the second is it going to move that electron, basically the kinetic energy of electron. Is this clear, beta? Clear na? So this is going to be happen, and this line is important. This energy is going to be absorbed by the electron and is used in following two ways. Okay, so the two ways are something like this. So you can rewrite this thing, the absorbed, okay, the E, or you can say quantum of energy, which is the E, the quantum of energy E equals to h nu, absorbed by electrons, absorbed by electrons. Okay, and it is used in two ways, and the two ways are, first, the ejection of electron, as you can see here as well. First this thing, the electron is going to eject from this inner valence shell, right, and going to reach at the surface. And the second is it is going to move also. Motion of ejected electrons. Ejected clear? So the beta first is in two ways. The first is ejection of electrons, that is known as photoelectrons, and the second is motion of photoelectrons. I can write now. Clear? Emission of photoelectron by a metal surface when a quantum of energy is absorbed. Emission of photoelectron by a metal surface, this is the same thing. Okay, so that you are going to find it. Clear, everyone? We already know this thing. So let's moving ahead. So this quantum of energy, okay, a part of energy is used to overcome the surface barrier and come out as the metal surface. This part of energy is called the work function. Work function is phi naught h nu naught. You can write here as well. Work function is W naught also, and that is also h nu naught, where nu naught is the threshold frequency. Okay, the remaining part of energy is used in giving a velocity v to the emitted photoelectron. This is equal to the maximum kinetic energy of photoelectron, that is half mv square max, where m is the mass of the photoelectron. As simple as that. Clear? So again, this basic equation, we have E, total energy, that is h nu, is nothing but work function or this W naught plus half, or you can say, I'm not going to write even this, AE of what? Kinetic energy of photoelectrons. So this is the basic general principle equation, as simple as that. Everything is related to this general equation. Why should I write this? Because even you learn this particle nature, even you learn the wave nature. General equation of PE effect. That is this. Okay, everyone. Clear na beta? Good. Now moving ahead. We already done this thing according to the law of conservation of energy, h nu. Okay. E equals to h nu equals to phi naught half mv square, and then half mv square kmx is going to be this. So this is one of the important equation also. Okay. So you can write this equation number 2. Okay, so this equation is called Einstein photoelectric equation. and we know this one is also called the Einstein photoelectric equation. You can write this as a equation. Moving ahead, we done this, we know this. So the maximum kinetic energy is given by K mass h nu minus u, and you can put this K max also EV naught. So this is the relation between this. Okay, this is my second equation. We know this is the third equation. Here V naught is something you know also, stopping potential. Okay, that is stopping potential. We discussed this thing, small things in the previous classes, right? So again, then EV naught equals to h nu naught minus nu naught, h nu minus nu naught. If lambda is the wavelength of the incident radiation and lambda is the threshold wavelength and c is the velocity of light, so you can rewrite this equation number 4, or you can rewrite this equation number 4 into the terminology of lambda also. Why so? Because c is speed, and that is lambda into frequency. Okay, this one. So if you know the frequency and this c, speed of light, we already know general thing, so we can find the lambda. Lambda is nothing but c by nu. Clear na beta? This thing we already done this thing so many times. Okay, so these are the important relations. I already give it to you. You already know this thing. So what it is, as it is written over, a relation between stopping potential V naught and threshold frequency. Okay, but it is, you can see the important relation. The relation, the relation between stopping potential stopping potential, that is V naught, and lambda, and lambda and lambda naught. Okay, clear beta everyone? Do you have any question, query till now? Is this clear everyone? Is this clear now, everyone? No, sir. Let it, sir. No, sir. Okay. So this is just verification of laws of photoelectric emission based on the Einstein photoelectric equation. So Einstein photoelectric equation, you don't get h nu equals to nu. Okay, this work function plus work function plus ke. Einstein photoelectric equation is written in the reverse way, that is h nu minus work function, and work function is already h nu naught. Okay, so this is this Einstein P equation. The same thing but in a reverse way. This equation is successfully explain the laws of photoelectric emission. These are as if V equals to V naught. Okay, we already done this thing. Let's re-revise. If V equals to V naught, then half mv square is negative, which is not possible. Why? So therefore, I mean, you cannot get negative kinetic energy ever. If you get in any case, so you are doing some mathematics, you can say mathematical thing wrong. Why kinetic energy cannot be negative? Do you think? What is the physical significance of negative kinetic energy? If I'm asking you this, Explain on what basis kinetic energy can also be negative. Then how are you going to explain? Or why kinetic energy cannot be negative? If I ask you why, so tell me why it is. I mean, why we cannot say kinetic energy is going to be negative and this photoelectric emission is going to be done. We neglecting this main important phenomenon on the basis of this only, like negative energy, kinetic energy is not possible. But why? Do you know this thing? Anyone? Very simple and logical even. Anyone, beta? See, generally, kinetic energy is half mv square. Clear, everyone? So, kinetic energy is dependent on two things. Half is a constant, right? V square. This thing never ever going to be negative. Physical significance means if you multiply any particular vector quantity to itself, so it always gives you a magnitude, and the magnitude is a positive. Magnitude can never be negative. Okay. In general sense, you cannot say I give you negative 10 apples because it is a magnitude. Clear na? Isn't it? It is not going to be in this way. Clear? Everyone, you understood? Like you cannot say, even if you take, so you can say I take. You cannot say I give negative 10 apples. Negative is nothing in general day-to-day life. So that is why if we talk about velocity, so yes, velocity can be negative because it is going to be in a reverse direction. You can say if you are going to move in this particular towards me, so the negative velocity is away from me. Clear enough? But the square of this is going to be never ever negative. In a same sense, the second thing is kinetic energy dependent on mass. If this particular thing going to be negative, so only one thing can be negative, the mass. But again, mass cannot be negative because negative mass, again the same thing what I explained you a minute ago. Negative mass is something is decay. Okay, we can say negative mass only in some important cases. For example, rocket propulsion, in which mass is going to be less after some time, and it is a large in quantity initially. That is what we say mass is decay, or it is going to be less, because what it is mean, and even that mass is not negative. There also the change of mass is negative, not the mass is negative. Got it? That is the difference even. Means initially we have higher mass, m naught is you can say 10 kilogram and m1 is 8 kilogram. So then change in mass is going to be m1 minus m naught, and that is going to be negative. It means it is decreases, not mass is negative. That is not something. And even if it is something, so at your level it is not something. Okay, I mean you can see in masters or even in PhD any particular concept in which mass is going to be decay at the tremendous rate. Tremendous rate means exponentially. But even then you cannot say mass is going to be negative, because negative mass is nothing. Even we have an anti-electron, positron. The mass of the electron is remain same. Charge is going to be alter. Got it? You hear this term, na? Positron, ions. So what it is, we can just change the charge from negative to positive. We cannot say the mass is changed 9.1 into 10 to the power minus 31 kilogram to minus 9.1 10 to the power minus 31 kilogram. So negative mass is nothing. You can say any particular sense or any particular you can say physical quantity or aspect. So that is why kinetic energy can never ever be in existence. Got it? You got not the physics behind it. Why kinetic energy? Never ever in a real case or in physical aspect, because mass on any particular case, on any particular scenario, can never be negative, and velocity square can never be negative, because velocity into velocity always a positive thing. Got it? Because it turns out into the magnitude. So that is why if you get the negative kinetic energy, means you are doing something wrong. And on the basis of that, once we get this particular relation, and on the basis of this, if this is the scenario, if my frequency is lesser than the V naught, so directly I can say that kinetic energy is negative, and this equation is not going to be done. Got it? In the same sense, since one photon emits one electron, so the number of photoelectrons emitted per second is directly proportional to the intensity of incident light. That we already done. Here the main thing is this. Moving ahead, it is clear that half mv square is directly proportional to V, and H and mu naught are constant. This shows that the kinetic energy of the photoelectrons is directly proportional to the frequency of incident radiation. Because this is material dependent, it is not having any particular relation and anything related to the incident radiation, either intensity, either frequency. Okay, so that is material dependent, and that thing is Planck constant. We already put as a constant. Say this is a constant, 6.636 into 10 to the power minus 34 joule second. Okay, so when this and this are constant, so obviously if I can say Ke, which is half mv square max, and that is equals to h nu minus h nu naught. Okay, so then Ke K dot E is directly proportional to what? V. As simple as that. This not even V, this is nu. Okay, this is clear now, everyone. So that is what I mean. Simply, it is written in this way. The next thing, the photoelectric emission is due to elastic collision between a photon and an electron. As such, there cannot be any significant time lag between the incident of photons and emission of photoelectrons. On a much deeper level, you can understand the photon and electron are in the state of elastic collision, and in elastic collision, the transfer of kinetic energy is going to be very quickly, because both the things are going to be conserved. Momentum and kinetic energy also. Clear na? Because in elastic collision, momentum as well as kinetic energy going to be conserved. In inelastic collision, momentum is conserved, kinetic energy going to be lost into some another form, light, heat, sound, any other form. So just take a break for 5 to 10 minutes, and from this we are going to start again. Clear? I speak a lot, so I need to Hello, 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 hello. Am I audible, beta? Hello, everyone. Hmm. Okay, so we revise, you can say, understand or everything. The P effect on the basis of Einstein wave theory or Einstein aspect, and these are the important graphs. Okay, so graphs related to photoelectric effect from Einstein's photoelectric equation. So Einstein's photoelectric equation is a little bit altered or changed. You can rewrite in this way. The general equation you know, right? So that is your Einstein's PE equation. So on the basis of that, the important graphs are related to photoelectric effect. That first is the frequency V and stopping potential V naught graph. So we know that EV naught equals to H mu naught minus work function. So then potential, stopping potential V naught is H nu divided by E and work function divided by E. We already done this thing in the previous class. So from this relation, what we can find the simple thing. This stopping potential is directly proportional to frequency because this is fixed and charge on an electron is also fixed. So in this way, you can find this relation. This negative aspect is this. I mean, your stopping potential can be gone into the negative range because of this equation 1. Okay, and from this we can directly find this tan theta is slope, and slope is this is not L. This is this. You can say H by E. This is your slope. This is your slope in between this graph for this particular thing, which is stopping potential and frequency. Is this clear now, everyone? Even I give you this relation in one of the question in the previous class, if I'm not wrong. Got it, everyone? In one of the question, I remember this. I give you this relation. So that is simple. So it could be seen that V naught versus V. This V is mu. Curve is a straight line with slope, and slope is tan theta and change and M and H over E. So that is everything. Clear, everyone? Good. Then moving ahead, in a same sense, you can find the relation between or a graph between kinetic energy maximum and frequency. So same thing we can going to find. Ke max is directly proportional to frequency, and as we know, in Ke max we don't need to divide this equation with this particular thing, which is electronic charge E. So that is directly your tan theta is going to be constant, and that is H. Clear, everyone? Or you can because it is K max, not V square and something. In the same sense, if you want to find the graph between V square K max, you can put half mv square. That okay? Wait, as we know, Ke uh, Ke max is half mv square max, right? And that is H nu minus this work function phi naught. So from here you can get the relation between V square max. Here V square max is the velocity, maximum velocity square, and that is H over, I mean I can put 2 also, but 2 is a constant thing. So let's forget about it, or you can say multiply 2 in both sides. So 2H over M divided by nu, oh sorry, and that is again 2 by M phi naught. Clear? So I'm not interested in this because this is I'm going to vary, but I'm not varying this because it is a constant, right? It is material dependent and a constant. So this is going to be constant. Once I fix the mass, it is going to be vary. So for varying thing, if I find V square max also directly proportional to the frequency, here slope is going to be m equals to tan theta. Here slope is going to be m equals m equals to tan theta equals to 2h over m. Okay, like in the previous case, we have a slope h over e, h divided by e. Here for kinetic max, directly we have directly proportional h, and tan theta is going to be constant. A slope is going to be constant, which is h. Here we have a slope m tan theta 2h over m. Clear everyone? Is this clear now, everyone? Okay. Good. Then this is your curve, or you can say relation between frequency V and photoelectric current I. So that is the directly graph until unless you don't have this frequency, which is threshold frequency. So the current is not going to be evolved. Obviously, it is not going to be evolved something like this directly, but in this range you can get it. Okay. I need to read all this. Wait a while. Yeah, this is not correct. This is something. So you get a current something look like this, and then at a particular certain time, after a certain time, it is going to be something look like this. Okay, yeah, this one is perfect. So this is your saturation current. This becomes the saturation current. Saturated current. Basically saturated photo current. Clear everyone? Why saturated? Because it is become constant after a certain time. Clear? So the graph given below shows that the photoelectric current I is independent of the frequency of the incident light till intensity remains constant. Intensity needs to be constant. Okay, so it becomes a constant. I mean, this I becomes a constant. I here is current. So many things. I here is photo current. Don't confuse this thing in a intensity. Photo current. Okay, so when you can say this everything you can see at constant intensity. Constant intensity. Intensity. At constant intensity. Got it, beta, everyone? Okay, moving ahead. This is your relation. Graphs related to photoelectric effect from the Einstein's photoelectric equation. Intensity and stopping potential. So that is not interested. I am saying that is not related. Stopping potential doesn't relate to this intensity. So that is for this. Okay, graph V naught versus intensity and photoelectric current I versus time. So that is in this way you can find it now. Okay, so these are the important ones. Both directly you see the graph like this, and the phenomenon is written over there, which particular phenomenon is based on these graphs. For example, diffraction, interference, E effect, resolution power, or resolving something so and so, or polarization maybe. Okay, or energy spectra, Bohr energy spectra, because we're going to learn these things what I'm saying right now, or something the other names. So two ways questions on the graph you can get. What is the particular correct graph or correct curve for the particular phenomenon, or the given graph is related to that which particular phenomenon. So you need to know this directly in general. Got it now? Okay. Moving ahead. This is the particle nature of light, the photon. We done this thing also, I think, but let's you can see revise this and revise this in a great detail. So photoelectric effect thus gives evidence that light consists of a packet, and that particular packet is known as photon. Packets of energy. These packets of energy were called light quantum. Quantum is what in general quantum is going to be used for a particular quantity. Okay, one quantum stands for one quantity. For example, if I'm going to say uh, I need to distribute the trophies to the students who come uh, first in each class. So obviously, if my school is I mean, if in my school I you can say open a school till 10, okay, first to 10. Not I'm not including this LKG, UKG, and so and so. So obviously, I know in each particular class, if I have three sections A, B, C, not four even. So I required 30 trophies to distribute because in each section there is a first prize I need to give, right? So that is quantity, quantum of or number of gifts or trophies I need to distribute. I need to give to the each particular student who is in the first in its I mean in his or her prospective section. Clear, everyone? Clear na the meaning of quantum here? So in the same sense, when I say light quantum, basically a quantity which is going to be related to the light, and that is known as a packet of energy, and that is known as a photon. A particle associated with this particular single quantum, single quantity is known as a photon. And that particular particle is, you can say, massless, and another properties and energy of this and momentum of this and so and so we're going to learn. Is this clear, first of all, everyone? Clear na? So from the photoelectric effect, what we can understood, the energy not only transfer in just continuous way, but it can be transferred into the number of energy packet, and that one single energy packet is known as quantum of energy, and that quantum of energy is treated as a particle, and that particle is photon. Clear? The whole soul definition now. So that is a photon in general. Okay, so that are associated with the particles named as a photon. So photons confirm the particle nature of light also. That is how they confirm the particle nature of light. Energy of a photon, we discussed this thing, E equals to h nu hc by lambda. You can find this energy with the help of dimension analysis. Clear? Because energy have a joule and h have a Planck constant, that is joule into second. So if I'm going to multiply with the second inverse this, so in a both okay, this h nu. Why so? Because joule have a unit, but I'm saying Planck instead have a unit, joule into second. So you can get again unit of energy, that is joule. Clear, everyone? So that from that relation you can find this thing. Okay, good. So E equals to h nu hc by lambda, where h is the Planck constant, v is the frequency of the radiation or a photon, c is the speed of light, and lambda is the wavelength of a photon. The momentum E by c, h nu by c, h by lambda, kilogram meter per second. Okay, that is meter per second. So that is important, and that is important also. Both of the relation are important. Important. Okay, moving ahead. Another different characteristics. Okay, this is something related to STR. I am going to little bit give a light on this. Just stay. So different characteristics, properties of photons are given below. In interaction of radiation with matter, radiation behave as if it is made up of particles called photons. Means radiation. Now this is a very important line. What I'm doing. This is very important line. Whenever radiation or this particular any kind of what is radiation? First of all, any particular kind of wave, any particular kind of wave related to the light or source of light. Okay, that is radiation terminology here. So whenever radiation is interact with the matter, matter is a kind of a metal, photosensitive metal. So that radiation behave as a particle. Got it? That is the meaning of saying quantum of energy or energy packets. So that radiation is behave as a particle, and that is why we say this particular thing. The collision between the photon and electron is elastic because only and only collision can be done in between the particles. You cannot see the collision in between the waves. Got it now? So that is what is the meaning of this. In interaction of radiation with matter, radiation behave as if it is made up of particle, and that particle is photon. A photon travels at a speed of light c in vacuum, and we know everyone c is speed of light, that is 3 into 10 to the power 8 meter per second. Now this is important. The rest mass, okay, the rest mass of a this particular particle, which is photon, is 0. The photon cannot exist at a rest, means it is always in the motion. And if it is a charged particle, or you can say if a particle is always in the motion, so it creates a wave, because it creates a magnetic field whenever a charged particle moving. So it creates a magnetic field, and obviously if a charged particle is even at the rest or in the motion, so it creates electric field as well as. And then again combination is going to be give you a EM wave. So according to the theory of relativity, as I told you in the beginning, STR. Okay, I give you some hint about this. So this STR is basically theory of relativity. This is special theory of relativity given by the Einstein itself. The mass of a particle moving with velocity v comparable with the velocity of light c is given by this. So in general, what we can see, rest mass of each particular particle. Okay, it is for in general. If any particular object, suppose this is your object of mass m, if I throw this particular object with this speed of 0.7 c, it is quite high, 0.2 c. Okay, what does it mean? The velocity of this particular particle is this 0.2 c, means 1/5 of light, speed of light. So your mass can be altered. I'm not saying negative. This is going to be changed, and change is going to be in this way. Okay, so here m naught is rest mass, and this m is mass of a particle or of object. I am saying about object, so you can say mass of an object moving with what? Moving with velocity this much. Okay, and you can see this effect only on at this range. At this range, saying means 1/100 or 1/1000 you cannot get, because it is quite low. And you can say 1/100 of c, approximately to the c, saying that 1/100 can be 1/1000 can be acceptable, but below 1/1000 cannot be acceptable, because with that we can throw the satellites or objects out of this earth. Okay, so they cannot change their mass in this way. They can change their mass something in another way. For example, what I given you example for a rocket system. Okay, so they cannot change mass in this way. Only if your velocity is going to be related this much. Even this much is going to be very less, but still 1/1000 of a c, because this can be become 3 into 10 to the power 6 meter per second, and which is 3000 kilometer per second, isn't it? So even this range cannot going to be work. This range is going to be work only 1/100 of c. Got it? Because 1/100 of c is something related to c, 0.01, but 1/1000 it's not. You can convert this thing into the kilometer and so, with which satellites are going to be thrown out of the surface of the earth. Got it now? I'm saying something you hear first time, or it is quite a known thing. Okay, so this is acceptable only, not 1/1000. Wait. this is acceptable. Okay, so this is what yeah. So mass is going to be changed. Mass is going to be changed when it starts moving with the speed of light, and obviously that is why the fastest experimented, or you can say the fastest observed speed is speed of light, that is 3 into 10 to the power 8 meter per second. Clear? Is this clear, everyone, beta? Okay, good. If it is so. So this is everything just in the written proper format, where m naught is the mass of the particle at rest. As a photon moves with the speed of light, that is v equals to c. So hence m naught is going to be 0. Why? So because m is m naught 1 minus beta square. Okay, I can put beta. You can see these words in higher classes if you choose physics. Here beta is v by c. Okay, got it now? So if v is going to be c, so beta is going to be 1, and then you can get the infinite mass. So obviously infinite mass cannot be there. So hence m not going to be 0. Clear what I'm saying? 0 by 0. Do you know L hospital rule? There are 7 or 6 quantities which is undefined. 0 by 0, infinite by infinite, infinite to the power 0, and so, 6 and 7. Okay, and in which you need to apply L hospital rule. I don't remember the L hospital rule, but I remember these quantities. Okay, so yeah. The inertial mass of a photon is m equals to E by c square. E you can put hc by lambda, h by c lambda, h mu by this. That is coming from mass energy equivalence. E equals to mc square. Here, so mass of a photon you can get from this. Photons travels in a straight line. One of the important property. Okay. Irrespective of the intensity of a radiation of all the photons of a particular frequency mu or a wavelength lambda, the same have the same energy E equals to h mu, that is hc by lambda, and momentum h mu divided by c, h by lambda. So that is again P equals to h by lambda, and this h nu by c, and E energy is you can say P into c, and that is hc by lambda, and that is h nu only. Okay, obviously we give energy first, then momentum. Okay, and how this come? Okay, then again, you think so much. Okay, momentum is mv, right? Is this clear? Or we can say in this case kinetic energy. Okay, or momentum is also that relation na ke is p square by 2m. So p is ke upon 2m under root. So E here is mc square and divided by 2m, 1 by 2 something and so and so. So C square is going to be remain. So E by C you can write it down. Okay. MV or wait. Mass you can find in this terminology. Okay. See momentum, sorry. Momentum of a photon. I'm going to write pH. So momentum of a photon pH. M into C, right? Because moment they travel with the V equals to C here. M is E by C. So E by C square, because we cannot have rest mass. So E by C square into C. So that is why E by C. Momentum of a photon. Got it? Why it is E by C? In this way you can prove that. Now these are the characteristics. Okay, let me see and then we can go ahead. So these characteristics, energy of a photon depend, and we already know this thing. Okay. So let's re-revise this. Energy of a photon depends upon the frequency of a photon. Yes, we know that. Energy of a photon does not, that is E, that is does not change when photon travels from one medium to another. So E equals to H nu. Simple. Wavelength of a photon changes in different media. So value of different media. Why so? Because V equals to C. Photon is C by lambda. I'm writing correct. Velocity is lambda. Now it is correct. So lambda is changed in any medium. Okay. So then velocity is changed. Frequency remains same. Photons are not detected by electric and magnetic field. This shows that photons are electrically neutral. In a photon particle collision, such as photoelectron collision, the energy and the momentum are conserved. However, the number of photons may not be conserved in a collision, and that is why it is known as elastic collision. Least but not last, photons may show diffraction under given condition. Okay, they show the diffraction pattern. They diffracted from their path. Now it is dependent on the PE effect, or you can say the reverse of the not reverse, based on the PE effect. Like the photon is going to give you I mean a photosensitive material. When a photon is going to interact, so the light energy is going to be converted into electrical energy, and we are going to use of this. Okay, not much in detail, but it is a kind of a cell, or you can say emitter, cathode, and that is anode. So the photons, or sorry, the photoelectrons is going to be travel in this way, and you can get a current. Okay, we discussed this thing in detail in diode, with the diode photocell. So in a device, it is a device that converts light energy into electrical energy. It is called, it is also called an electric eye, as a photoelectric current setups in the photoelectric cell corresponding to the incident light. It provides the information about the object as has been seen by R in the presence of light. A photocell consists of semi-cylindrical photosensitive metal plate C, emitter, and a wire loop. Okay, A, collector glass or quartz bulb. When the light of suitable wavelength falls on the emitter C, the photoelectrons are emitted, and these photoelectrons are going to be in the motion. So the flow of photoelectrons is going to be done, and we get the electric current. Okay, as simple as that. Applications. Some application of photocells are given as below. Used in television camera for telecasting scenes and in a phototelegraphy. Reproduction of sound in cinema film. Used in counting devices, used in burglar alarms, to measure the temperature of star, used for the determination of Planck constant also. Okay, so these are basically the important use. You can find it down from the. Now there is a question. Do this and tell me the answer. The electric field associated with a monochromatic beam of light becomes zero with frequency of this times per second. Okay, obviously frequency times per second means 1 by second or hertz. Find the maximum kinetic energy of photoelectrons when this light falls on a metal surface whose work function is given this. So you have a work function and electric field associated. Okay, you have a frequency also. So do then. You need to find the what? Find the maximum kinetic energy. So used directly Einstein PE effect or Einstein PE equation. PE stands for photoelectric effect. Okay. Here one catch is there. In complete one vibration, twice the electric field becomes zero. So the frequency is going to be half of that from the given thing. Okay. One catch is there only, or you can say one hint. This information hide in itself. The electric field associated with monochromatic beam of light becomes zero. So only electric field is going to be become zero when it is complete one side. Okay, so 2 frequency. So you can say frequency F naught you need to use here 1 by half into 2.4 into 10 to the power 15. That is frequency you know, frequency are you going to use here 1.2 into 10 to the power 15 hertz. Now everything rest is given to you guys. Use it in the formula, and the formula you also need to apply. I mean, I hope and I believe you know the formula. Formula is KE is HF, or you can say H nu. You can write nu this thing also minus work function. Because work function is directly here. But a Planck constant you need to remember, or it is given on the first page of this paper. 6.3 into 10 to the power minus 34. Okay, one answer is D. Another D is correct or not, everyone? B. Anyone else? One say D, one say B. A or C also someone get or not? Arey beta, you need to use this equation. And obviously not this, this precisely. Because it is given in the EV, electrovolt. So that is exactly the correct answer is B, not D. Got it, Vishwanath? In this way. So given work function 2 electron volt, H is this, E max you need to find. So E max is H nu minus work function. V frequency is, sorry, 1.2 into this. Okay. Next one, the momentum of a photon of electromagnetic radiation is this. Find out the frequency and the wavelength of the associated with this. Momentum is given. You need to find what? Okay. Frequency you need to find. Wavelength you need to find. Go ahead. Sure, tell me the value of this, and I'm not going to give you a hint or formula for this because after that is nothing. Just one page below, the last page, I give you how photon momentum, I mean what is the photon momentum and this into the terminology of frequency and lambda. Do this and tell me the answer. Tell me, beta, what is the correct answer? Sir, frequency is 1.5 into 10 to the power 13. I need to check, beta. I don't learn by heart. I know the formula. Frequency is yes. And lambda is C by frequency, that is 2. Okay, so 2 students get it. So we can go ahead. Okay. So in this way you can find it down, and simple thing, as we know, P equals to E by C, that is H by lambda. So first you can find lambda, okay, and then you can find nu also. Why so? Because C is lambda into nu. So beta, if you know the lambda, we can know the nu. In this way they can find those even, in the reverse way even. Okay. So the correct answer is this and this. Okay. So in this way we completed this lecture even. Okay, Einstein's photoelectric equation, energy quantum of radiation, particle nature of light, photon, its properties, and then we also done this photocell, important graph also we cover. Okay, so this much we done in this particular lecture.